What is the difference between nuclear charge and effective nuclear charge, and how do you increase effective nuclear charge? Nuclear charge is the total positive charge of all the protons in a nucleus of an atom. Effective nuclear charge is the nuclear charge experienced by the outer shell electrons. Effective nuclear charge is lower than the value of nuclear charge. The effective nuclear charge increases when there are more protons pulling the valence electrons, which makes the atom tighter. What does increased effective nuclear charge do to the atomic radius? As the effective nuclear charge increases, the atomic radius will shrink as a result, because there is less screening of the electrons from the nucleus, which increases the attraction between the nucleus and the electron. Francium has a greater nuclear charge, more protons, than fluorine, but has a much larger atomic radius. How can this be? More protons in an atom does not mean an atom is bigger than another. More protons does mean there are more electrons, therefore more shells. These may lead to a bigger atom. Due to the higher effective nuclear charge, the protons pull the electrons, which causes the atom to be tighter, and it will reduce size. Fluorine has less protons, but also less effective nuclear charge, while francium has more protons and more effective nuclear charge, which will cause the atom to get tighter and smaller. How does atomic radius affect ionization energy? Less atomic radius causes higher ionization energy. This is due to the fact that the closer the electrons are to the nucleus, the more stable and relaxed they are. More ionization energy is required to take one of them. If bromine has more protons than fluorine, how can ionization energy be lower than fluorine? In the periodic table, we can see that fluorine is located higher than bromine. Since it's higher, it has less protons, which indicates that its valence shell is closer to the nucleus. The closer to the nucleus the valence shell is, the higher ionization energy it takes to take an electron, since it's more stable and more relaxed. More electron shielding reduces one variable, negative correlation, and increases another variable, positive correlation. Identify variables and explain how it works. The decreasement of ionization energy is the negative correlation of electron shielding. Decreasing ionization energy causes effective nuclear charge to increase. The positive correlation is the increasement of effective nuclear charge. The more electron shielding, the more its repulsion for the outer shell of the electrons. This makes it easier to take an electron. The atomic radius, electron shielding, and ionization energy of gases are reflected when compared to the metals. The atomic radius of gases is usually smaller than that of metals. While regarding ionization energy, the metals have higher than gases. As the atomic radius increases in metals, the ionization energy decreases. The electron shielding in gases is lower than the metals, since metals have larger atomic radius. Show the relationship between ionization energy and atomic radius on a graph. This graph shows that as the atomic radius decreases, the ionization energy increases. Create a rule for ionization energy and atomic radius as it approaches F on the periodic table. As it approaches F in the periodic table from left to right, ionization energy increases. This is due to the fact that as you go across the periodic table from left to right, the number of protons increases and the atom gets smaller in response of the pulling of extra protons on the electrons. The ionization energy increases since the outer shell of the electrons gets closer to the protons in the nucleus. Moving from the right to left increases atomic radius since it decreases ionization energy. The rule for ionization energy we just created will also apply to what other variable and why. The rule for ionization energy I just created will apply to electronegativity since it also increases from left to right. As the number of protons increases, moving from left to right in the periodic table, electronegativity increases.